Number 21 is x minus 8 over x plus 1 minus 6x minus 2 over x plus 1. This is the top of page 272. You guys with me? This one's not bad at all. It's just bigger. Common denominator between 1, x plus 1, and x plus 1 will be x plus 1. Thank you. Okay, so by multiplying this fraction by x plus 1, you end up with x squared plus x over x plus 1. And the rest of it is already in the proper position. Okay, this is where it gets a little bit tricky. Okay, you've done this, but I don't want you to screw this up. Remember, the negative symbol here acts on this piece. The negative symbol here acts on both of these pieces. Okay, so because the denominator is the same, the numerators get combined according to the operation indicated. Okay, so the first one is x squared plus x minus 8 minus 6x. And what does that minus do to the negative 2? Positive 2. Good. All of this is over x plus 1. Okay? Wherever you can collect like terms, you're going to want to do that. There is nothing to do with the squares, so it sits there. I kind of cross them off as I go. Positive x, negative 6x, negative 8, positive 2, negative 6. All of that over x plus 1. You think we're done? Yes, no, maybe so? Do you think there's any chance we could reduce the x plus 1 with the numerator? How would you know? What must you do to decide that? Factor it. Good. Thank you, Jared. Factors of negative 6 that equal a negative 5. Negative 6, positive 1. So we're factoring. I keep threatening you that this never goes away. Factoring never goes away. It doesn't. Okay? Final answer, x minus 6. That's all you need. Okay? Number 23. Another one that has 3 parts. But this one is not all subtraction. B minus 1 over B minus 3 over B minus 2 plus 1. Lowest common denominator of B minus 2, and B minus, and 1. Anybody know? What about the B? So your lowest common denominator is going to be B and B minus 2. Remember the rule for finding common denominator, the largest power of any factor present. Okay? B is present one time, B minus 2 is present one time. If you only do B and say B, or if you only do B minus 2 and say that's the common denominator, what will you do to the B to make it B minus 2? There's nothing you can multiply this by to change it to B minus 2. Okay? Largest power of any factor present. This factor is present, and this factor is present. Remember, normally, when you do numbers, you're able to see by prime factoring what the largest powers of the factors are and put those together. Well, this can't be factored any further. So this is your denominator. And it'll look like this. B minus 2 in the first fraction, B minus 2 in the second fraction, B minus 2 in the third fraction. You will need to be at home, quiet, and paying attention to everything I have taught you in order for you to be successful at this. If you are not focused, it is so easy to make foul-ups, I'm telling you. So, what must I multiply b by to get b times b minus 2? B minus 2. Okay, you doing okay? So, b minus 2 times b minus 1, I'm going to FOIL it right now, okay? B squared, it's kind of hard to FOIL it when it's like this, outside negative b, inside negative 2b, so negative 3b, last positive 2. Okay, b squared, outside, inside. Okay, this one, what must I multiply the 3 and the b minus 2 by to get it to b minus 2? b, that's a little easier, isn't it? 3b. And this guy, in order to make a 1 that, you have to multiply both pieces by b minus 2. So you end up with b minus 2 there. Okay, you know what, let's just FOIL it, or distribute it, b squared minus 2b. We're going to need all that anyway. According to the rule, when all of the denominators are same, the result is the combination of the numerators according to the operations affecting them. So we're going to combine all the numerators. B squared minus 3b plus 2 minus 3b plus, this doesn't change anything, b squared minus 2b, all of that over b minus 2. Notice I'm not multiplying this out, because in factored form, it is much easier to see if there are reducing options there. All right, let's start combining some stuff. The b squareds go together. 2b squared. Negative 3b, 2b, negative 8b. And 2, all of that over b minus 2. Okay, in order to reduce this, hopefully, we need to find a greatest common factor. 2, 8, and 2. Well, that sounds great. Let's see if that helps us. 2b squared minus 4b plus 1. Okay, I factored that out. Does the 2 help this or that? Okay. How about factors of 1 whose sum is a negative 4? Does that exist anywhere? Yeah, that's your answer. You didn't even have to, you can't reduce it. Okay. So if you leave it 2b squared minus 8b plus 2 over the denominator, that's fine. But you're going to factor it anyway because you're going to look for a way to hopefully reduce it. And at this point, you've shown me that I'm trying to reduce it, but it's just not reducible. Okay? I'm going to skip ahead to number 29 because all of 25 and 27 are just the same thing. Okay? It's just the same way. Bigger numbers maybe, smaller numbers maybe, no different. 3x, so this is number 29, minus x squared over 2x plus 3 minus 2. Ooh, this one's actually pretty easy, isn't it? Greatest, lowest common denominator of all of this?
2x.
Mm-hmm. Okay. To convert this to this, multiply both pieces by 2x plus 3. So that gives you this times this, 6x squared, that times that, 9x. This one doesn't change, does it? And to get from here to here, multiply both pieces by 2x plus 3. I see you. Come back to me. There you go. Okay. That gives me 4x plus 12 here. Denominators are all the same, so all the numerators get combined according to the operation in between. So let's start with the left. 6x squared plus 9x minus x squared, this x upon both of those pieces, minus 4x minus 12. All right? Almost done. Combine everything where you can. 5x squared, 5x minus 12. 2x plus 3. Okay. Two times 3 is 6, Mrs. Myers. Surprised nobody caught me. 2 times 2 is 4. 2 times 3 is not 12. It's 6. Doesn't help us, though. Factors of 30, whose sum is 5. 1 and 30, 2 and 15, 3 and 10, 5 and 6. That's your answer. Can't factor it. 31 and the rest of them. We are now multiplying. Holy cow, how do we do that? Okay. It's not as hard as you think. Lost my place. Okay. How do you think we're going to do this? Anybody have any ideas?
Least common denominator.
Well, we're multiplying, we're not adding. We're multiplying, we're not adding. Factor? Why do you want a factor?
Because it's within a factor.
I kind of don't like these. Here's the easiest way to do this. Okay, I'm going to just tell you right off the bat. There's two schools of thought here. You might look at this and say, I'm going to FOIL, first, outside, inside, last, and deal with that way. Don't do that, okay? What you're going to really want to do in order to multiply these, first combine what's in parentheses, which means you have two addition problems. Is that what you were trying to say to me?
I was trying to say like 4.
Okay. Okay. So the lowest common denominator of this, let's just solve this little addition problem, is A, right? Multiply both pieces by A. Okay, just look at this for a moment. Just look at that. So I have A squared over A, right? In this first spot, A squared over A added to 2 over A. Am I right so far? Okay. The answer here is A squared plus 2 over A, right? Next piece. Same thing, right? A. Okay, I'm going to just parenthesis that for now. Over here, A squared minus 2 over the A's, okay? I just A, okay, figured that out. A squared over A minus 2 over A. That looks like that, okay? Now you're going to want to FOIL, and I want you to look at this, not FOIL per se, but I want you to look at this like you're simply multiplying the two numerators. a squared times a squared is a to the fourth, right?
Yeah.
The outside is a negative 2a squared. The inside is a positive 2a squared. That cancels out, right? Last, negative 4. Okay, you all know how to multiply this times this.
And then you can,
You all know how to multiply this times this.
that's a perfect square, isn't it?
A times A. There's your answer. Okay? So I don't want you to look at this and go, I just don't get it. Okay, add them together or do whatever the manipulation is within the parentheses first before trying to multiply. Remember, the order of operations tells us do what's in parentheses first. Well, the only reason we FOIL is because you can't do anything in parentheses, right? Here we could, all right? That's what this is all about. So combine each fraction. Here we added, here we subtracted. Then look at what you have. There's nothing else you can do, so you're going to multiply according to the normal rules. Numerator times numerator. Okay, well, in order to multiply those two numerators, I got to FOIL them. Denominator times denominator. No problem. Can we reduce? No. Okay, you could look at this and say a squared plus 2, a squared minus 2, but you already know that that will not reduce that anyway. Okay? This is the entire rest of your lesson. Okay, 30, 31, 33, etc. I'm going to do a couple more. I know I'm taking a lot of time, but I know this is going to be something you're going to struggle with later. A plus b over a minus 1 multiplied by okay, you're not going to want to start messing with this until you combine what's in parentheses. We can. If I create a common denominator here and add the fractions together, I will create something that can be multiplied. A is going to be the common denominator between a and 1, right? Multiply both pieces by a. You end up with a plus b over a minus b. A over a. Okay? What do you end up here? A plus b minus a. B over a. Okay? Over here, common denominator is b, right? Multiply both pieces by b. And you get same thing here, same thing there. And this piece becomes a plus b over b. Okay? So we added or subtracted according to the operations, created this and this, and then combined. Multiply. Numerator by numerator is going to be ab plus b squared. All of that over ab. You with me so far, folks? You're going to think I'm crazy here in a second. Well, do you see anything that can be pulled out of this? B. If I break that apart, it's easier to see. Look, the b's cancel, don't they? A plus b over a is your answer. Now, do you notice the b's could have cross-canceled right here? Then you wouldn't have even had this step. Okay? So I want you to be aware that the cross-canceling laws hold here as well. I'm going to do 37 and then I'll let you guys go loose. I know, Clayton, I know. This is division, folks. All the same processes that we've just done these few examples. 1 minus 2 over a divided by 1 minus 4 over a squared. Okay, you with me, Gabe? What's the denominator for a and 1? A. So a over a minus 2 over a, right? Combine, you get a minus 2 over a. Here we are, common denominator, combine the numerators. Okay? Over here, denominator for 1 and a squared. Multiply, you get a squared over a squared minus 4 over a squared, and you end up with the combination of a squared minus 4 over a squared. Okay? To divide, you must multiply by the reciprocal of the second fraction, which is going to make this really convenient. Why did I take this and convert it to that?
Because it's a perfect square.
Because it's a perfect square. And isn't that going to help me when I try to multiply? The a minus 2's cancel. This a cancels, and that a squared becomes a to the first. Your answer in the numerator is a. Your answer in the denominator is a plus 2. Okay? If you don't recognize the cross-canceling and you follow suit and go and do all of it, then you factor it back out, you'll still discover the places that you need to cancel. It's not like you won't get there. It's just faster if you look at it before you multiply, just like in normal numeric multiplication.